All right, so the first problems that we do are going to be these average rate of change problems. So we'll be evaluating at each endpoint on the interval. That'll be the first thing, and then we'll move into tangents and normals and all that. So, number 2. So these say to find the average rate of change of the function over each interval. So f of x is equal to the square root of 4x plus 1. And they actually give us 2 different intervals to do it over. So the first one is 0 to 2. And then the other interval is going to be 10 to 12. So we evaluate at the second endpoint minus the evaluating it at the first endpoint. So the square root of, evaluated at 2, so that's going to be 4 times 2 plus 1 minus square root of 4 times 0 plus 1. And you don't have to like write it out like that with showing what's being plugged in. Like you could have just rewritten this as 8 or that is 0. Excuse me. But I'm just doing it just so if you go back to look, you see what's happening. And then over 2 minus 0. So the square root of 8 plus 1, so square root of 9 is 3 minus square root of 0 plus 1 is 1. Over 2 minus 0 is 2, which is 2 over 2, or 1.
Wait, is this the stuff that you said is like similar to rate of change and slope? Or is that something else?
This is average rate of change. The formula just kind of looks like the slope formula. So that's why I compare it that way. All right, so then now we're going to do it for 10 to 12. And maybe you're thinking, well, that's kind of like 0 to 2, so it's going to be the same answer. It's not necessarily the case because of how we plug it in. So anyways. All right, so the square root of 4 times 12 plus 1 minus the square root of 4 times 10 plus 1 all over 12 minus 10. So 4 times 12 is 48, plus 1 is 49. Square root of 49 is 7 minus 4 times 10 plus 1 is 41. Square root of 41, we don't know that off the top of our head, so square root of 41 over 12 minus 10 is 2. So that would be how you would end up leaving that answer because we can't simplify it down any farther. If you could simplify it or take things out of the radical, do it, but can't in this case. So, let's do one where we have to remember our friend, the unit circle. So same instructions. We've got f of x is equal to 2 plus cosine of x. And the first interval is going to be 0 to pi. Second interval is going to be negative pi to pi. So 2 plus cosine of pi minus, and I would probably put this in parentheses because both things are getting subtracted. If you don't, then you need to put minus 2 minus cosine of 0. So 2 plus cosine of 0. I'm going to do it in parentheses so that I don't have to worry about that. And then over pi minus 0. So 2 minus 2, that's going to end up canceling each other. So the cosine of pi is what?
Zero. Wait, 1.
So I think it's negative 1.
It's
Right? Get out our friend.
negative 1.
Cosine of pi would be -1.
Pi's over there.
So -1 minus cosine of 0 is
1.
over pi. So that's going to be -2 over pi. Once we get into stuff where we really need the unit circle, like with derivatives and stuff, or like later on, I probably will make you quiz on the unit circle, but I will not reteach the unit circle because you should have had it at least twice by now. So, all right, negative pi to pi. So 2 plus cosine of pi minus, in parentheses, 2 plus the cosine of negative pi all over pi minus a negative, so plus pi. So again, 2's are canceling. We already said what the cosine of pi was. That was -1. And then minus the cosine of negative pi is -1 times negative, so that's going to be positive, so +1 over 2 pi. So that's going to be 0. Oh, we got a diamond. All right, any questions on those?
No.
All right. So these next ones have multiple instructions. At the indicated point, find 1, the slope of the curve. 2, an equation of the tangent line. 3, the equation of the normal line. 4, then draw the graph of the curve, tangent line, and normal line in the same square viewing window. That's a calculator thing. You don't need to do that unless you just want to graph it on your calculator. So we're doing parts 1 through 3. All right, so number 10. Y is equal to x squared minus 4x at x is equal to 1. So I'm going to scroll back up. This. Okay, this limit as h approaches 0 of f of a plus h minus f of a over h. Okay, this is the formula you need to know. It's for the slope of the curve. So that's going to give us our tangent slope when it's all said and done. So the limit as h approaches 0. Now, in this case, x is a in our formula. Okay, so if you need to see it, there it is. So we have, in parentheses, 1 plus h squared minus 4 times 1 plus h. Now, I just want to make sure we're tracking here. 1 plus h has replaced x, okay, in this. I have only done the first a plus h part of that formula, okay, because I'm plugging in a plus h anywhere there's an x in that equation. So right now, I've only done part 1 of that formula, okay. Minus, now I would bracket this off so that there's no confusion because it's minus all of that. We plug in 1, okay, it's just plugging in a for x now. So that's going to be 1 squared, which is just 1, minus 4 times 1. All over h. And so now we're basically just multiplying and simplifying like terms.
Can you like go through that again and explain what each part is?
Yeah. So these first two pieces, so this 1 plus h squared minus 4 times 1 plus h, that is, I'm just going to scroll back up because it's easiest to see it. That is this f of a plus h part, okay, in the formula. Then minus f of a, which in our case was just 1. So this minus and then everything in the bracket is this formula this function evaluated at 1. Okay, and then it's all over h is the bottom part of that formula. Is everybody tracking?
Yes.
Okay. So now we have to keep the limit all the way down, so it gets really annoying, but we do have to write it all the way down. So 1 plus h squared is what?
1
plus 2
plus
h squared.
Yep. And that's what kind of special type?
Perfect square trinomial.
Perfect square trinomial. And then I've got to do minus 4 times 1 plus h, so minus 4 minus 4h. Then inside the parentheses, I've got 1 minus 4, which is negative 3, times the negative, so it's going to become positive 3. So plus 3 there, all over h. And just as a reminder, the whole reason I can't go ahead and plug in for h, the 0, is because I have h on the bottom by itself. So basically, what has to happen is we've got to get to the point on the top where h is going to cancel with the h on the bottom. So it's kind of nice because you know what the end goal is in this. It's always to cancel h. So on top, I've got 1 plus 3, which is 4, and I've got a minus 4, so all the numbers cancel. So now I'm going to combine like terms. Limit as h approaches 0. So this is going to be 2h minus 4h is negative 2h plus h squared all over h. And this is going to seem like a lot of steps the way I'm doing it right now, but you will not have to write all of these steps out if you can do them and like condense it down for yourself. So then the limit as h approaches 0, I can take an h out of the top, so h times negative 2 plus h all over h. So my h's cancel top and bottom. And so now rather than writing another step of rewriting it, I can just plug in 0 for h, because now I only have an h on the top, so ultimately my answer ends up being negative 2. Okay, and this was part A of that whole part, basically. It was part A of that question.
There's another part.
Yeah, that was just the slope.
Parts.
That's the slope for our tangent line. Okay. And then we will find the normal slope for part C. So just for you to reference, this is the slope of the tangent line for part B. So now the problem is I have a slope, but I don't have a point, and I have no other way I can graph a line or write a line at this point. But I was given that x is equal to 1, okay? So what might I need to do to find the y?
Plug in x.
Yep, plug in x. So basically my point is going to be, so I'm going to go ahead and write part B here, is going to be 1 and then f of 1, okay? So I'm going to evaluate that initial function for 1. So if I plug in 1 to that, I have, what is it, 1 squared minus 4 times 1. Yeah. Which is
-3.
-3. So now I have a slope of -2, and the point is going to be 1, -3. So now I have a slope and a point. So I can now write an equation of the tangent line. So y minus negative, so plus 3 is equal to -2 times x minus 1. If you would like to leave it there, that's fine. I don't actually know how the book leaves their answers because they don't have these answers up here in the front. Let me see if I can find it, just so that you're aware. What is this? 2.4.
Yes.
Number 10. Thanks.
2.
All right, so they actually do go ahead and put them in y equals mx plus b. 2.4. So they put them in y equals mx plus b, and the reason why is because I need to then, for part C, find the perpendicular to that line. So that's why they do that. However, we have the slope, so we wouldn't have to do that, but that's what they're doing. So I'm going to go ahead and put it into y equals mx plus b, but like I said, I'll take it like this. The other way I would take it is y is equal to -2 times x minus 1 minus 3. That's kind of the modified point slope form that this book uses. And then the last option would be y equals mx plus b, which would be y equals -2x. -2 times -1 is +2, minus 3, so -1. So this is my tangent line. And all three of these things are saying the exact same thing, just in a different way. And so lastly, part C, I need to find the normal line. So the normal line is perpendicular to the tangent line, and it's through the same point. So the only thing we need to do differently is the slope. So what is the perpendicular slope to what we had here?
Positive half.
Positive half, so it's opposite reciprocal. And then the point is still 1, -3. So y plus 3 is equal to 1/2 times x minus 1. So y equals 1/2 x minus 1/2 minus, I'm going to go ahead and make this 3 over 2 just so I can simplify it faster. So that's going to be 6 over 2. So then y is equal to 1/2 x minus 7/2. And this would be your normal line. So either of those two things there would be fine. Don't leave it like this in the middle. If you're going to do it, then leave it in parentheses and just subtract the 3 off the end. If for some reason you want to leave it like the middle way. But if you're going to check your answers, it's got to be in y equals mx plus b. All right, any questions on that? That's kind of honestly the bulk of this section. The hard part, the calculus part, is finding the slope. Beyond that, it's what, algebra 1, maybe, algebra 2. So, let's do another one. Let's do 12. Y equals x squared minus 3x minus 1 at x equals 0. So this one's going to look a little different. Any idea why?
Because
Because it's
obviously it's factorable or something. Actually, I'm not sure.
So what am I plugging in for my limit?
A 0.
So a plus h would be 0 plus h, so I only need to actually plug in
H.
h. So this one's going to be easier.
You're so true.
So the limit as h approaches 0 of, now keep in mind, the formula is still the same. The whole reason, I'm not going to write in the 0 because it seems excessive. But if you need to do that for reference for when you go back, that's fine.
Right.
But I'm not going to write the zeros because it's just 0. So a plus h, so that's just going to be h squared minus 3 times h minus 1. Okay, so that is the a plus h part. So since I'm not actually writing it in, I'll do this. This is the a plus h part. Minus, okay, now it's f of a, so a is 0, so x squared, that's gone. Negative 3x, that's gone, okay, because those would both be 0. So I have minus 1. So I have minus a minus 1, so that's going to become plus 1. So just for the sake of not having to write so much, I'm going to go ahead and write it that way. So this is, I'm going to do minus at a. Okay, just so if you look back, you see what's happening. And then all over h. So now on top, 1's cancel. And so I'm going to go ahead and take the h out of the top because I'm trying to write as little as possible. So the limit as h approaches 0 of h times h minus 3 over h. So h's cancel. So now if I plug in 0 for h, I'm left with negative 3. Negative 3. So this is part A. So my slope is negative 3. So for part B, I'm evaluating at the point 0 and f of 0. So if I plug in 0, I get negative 1. So that's my point, and my slope is negative 3. So now, point slope form, y minus the negative, so plus 1 is equal to negative 3 times x minus 0. So I'm just going to write negative 3x. So y is equal to negative 3x minus 1. So again, either of these would be fine. This is my tangent line. And then normal, what's my slope of my normal?
1/3.
Positive 1/3. So y plus 1 is equal to 1/3 times x minus 0, so just times x. So y is equal to 1/3 x minus 1.
Hey, can I run downstairs real quick? My brother's in the 15-minute parking lot. He just dropped off my new brakes.
Oh, yeah, that's fine. So you might need a key. All right, any questions on that part?
No.
We're good. All right, let's
That's like the
see.
bulk of this section though.
I mean, basically, if you can find the slope, you can pretty much do this entire section because for the most part, it's just plugging in things
Yeah.
to that equation or that formula. I'm not gonna say they're not harder than that at times, but it's doing that and finding the tangent line basically is like the biggest stuff in this section. All right, let's see. Determine whether the curve has a tangent at the indicated point. If it does, give its slope. If not, explain why not. Okay, so you're going to see what I'm talking about here in just a second because these problems look a little bit different, but finding the slope is the same thing, same formula. So it's f of x is equal to, and then it's going to be two things. So negative x at x less than 0 and x squared minus x at x greater than or equal to 0 at x is equal to 0. And so basically, we're looking to see if the slopes are the same for each of those. And so these are pretty nice because they do it at x equals 0. So this problem is a little nicer because, again, we don't have to, we're still doing a plus h and then just a, but it's 0, so we don't need to write it. So it'll make these problems slightly faster. So the limit as h approaches 0 of negative h minus, plug in 0, so it's just 0, over h. Are we tracking? Because obviously this is significantly shorter than the one before.
Reiterate what you just said.
Yeah, so basically I'm doing each of these separately like they're their own problem. And I'm looking to see if their final answer is the same when I take the limit. If they're not, then it doesn't have a tangent at the point that we're doing. So, anyway, so the first part is the a plus h, but a is 0, so this is just h. And then a is 0, so it's minus 0. So then I'm going to go ahead and just reduce this because I can. So that ends up being what?
0.
-1. Negative h over h is -1. So that one's -1. So if the other one is -1, then we do have a tangent and the slope is -1. If not, then it does not. So the limit then as h approaches 0, so now I have a little more to plug in, but a plus h still 0, so h squared minus h minus, evaluated at 0, it's just 0, over h. It's getting blurry. Let me fix it. So then the limit as h approaches 0 of h times h minus 1 all over h. So my h's cancel. So this is -1. So yes, it has a tangent at the indicated point. The slope is -1.
So why do you take away the h that's in the parentheses?
The h in parentheses.
Yeah.
So the h and the h cancel, and then I'm evaluating at 0. So I just am plugging in 0. I'm just trying to not write as much. So there's not an even one that comes out to not be a tangent. So I'm going to do an odd one really fast. Just so that you can see what happens if they're different. So 15. So yes, I'm backtracking. Hopefully that doesn't irritate you that your stuff is out of order now. F of x is equal to 2 minus 2x minus x squared for x less than 0, and 2x plus 2 for x greater than or equal to 0. Oh, and it's at x is equal to 0. So
I was about to ask. I was like,
yeah.
we're just guessing.
When you actually open the book and see, it's kind of been like the way it's written is like, well, it might not be as confusing in yours because mine has all the answers like side by side, so it's like hard to tell what's the question and what's the answer sometimes, even though it's like, yes, it's different colors, but kind of just all runs together.
Yeah.
All right, so top one, limit as h approaches 0 of, now a plus h, again I've got a being 0, so that's nice, so I'm basically just plugging in h for x. So 2 minus 2h minus h squared minus, okay, now I'm plugging in 0 for x, so I'm only left with a 2 on the top because the other two things go to 0. So minus 2 over, or sorry, yeah, over h. I was about to do the other one in with it instead of its own separate problem. So 2's cancel. I can take out an h, so the limit as h approaches 0 of h times negative 2 minus h over h. H's cancel. Evaluate at 0, I get
Oh, negative two.
-2. And then the other one, limit as, oh, not x. H approaches 0. Still a plus h, which is 0 plus h, so I'm just putting in h for x. So 2h plus 2 minus, evaluated at 0. That's 0 plus 2, so just minus 2 then over h. So this one, 2's cancel. Then I've just got 2h over h. H's cancel, so I'm left with
Why is
2.
it minus 2? If you were just plugging in.
If I plugged in 0 to x.
So wouldn't you just be left with positive 2?
Well, it is, but the formula is minus f of a.
Got it.
So I've got one that's negative 2 and one that's positive 2. So because these are different, or these are different, I should say, therefore, no tangent.
Is that like the 3 little dots? That mean therefore.
Yeah, 3 little dots means therefore. Why, I don't know, but it does.
Yeah, it's pretty interesting.
All right, the next one say find the instantaneous rate of change of the position function y equals f of t in feet at the given time t in seconds. So this is the exact same thing that we've been doing, but now it's t plus h. Okay, instead of a plus h. So it doesn't really change anything as other than that you're going to have units on these problems. Okay. And in this case, it's going to be in feet per second. So, I can get back to where I was. Probably get through one of these and then we'll have to finish up tomorrow. So 24 f of t is equal to 3t squared plus 2t. And t is equal to 3. So this one's going to be probably a little more work to it in a sense because we've got things being multiplied and factored and all that fun stuff. So limit as h approaches 0. On top, initially I'm plugging in t plus h now, so 3 plus h. So 3 times 3 plus h squared plus 2 times 3 plus h. So this is the t plus h part. Minus, and I'm going to bracket it off because there's going to be 2 parts. I don't want to forget about it. Now I'm just evaluating at 3, so plugging in 3 for t. So 3 times 3 squared plus 2 times 3. And again, if you wanted to go ahead and just multiply that and just fill in the number, that's fine.
All over.
All over h.
Love how it's just everything and just h.
Limit as h approaches 0. And I'm going to tell you too, sometimes when they get super, super crazy on top, I might honestly just work the top kind of on the side and then put it back. Just because it's like kind of seems like a waste to take up an extra line to just write over h. So. Like in this case, I'm going to do this for this 3 plus h squared. 3 plus h squared would be what?
9
minus 6h plus h squared.
So I'm going to do that there just for reference, and then I'm going to go ahead and multiply it by 3 before I write it, like as I write it down here. So 3 times all of that then is 27 plus 18h plus 3h squared. Because there's no point in me rewriting the whole thing to factor
Right.
one thing. Plus, and I mean, I trust that with perfect square trinomial, y'all can do that potentially just in your head. So if you didn't even show that, that's fine. Just if you do it wrong, just know that the less that's there, the less credit I can give. So plus, I'm going to distribute this too. So 6 plus 2h. And then over here, I've got 3 times 9, which is 27, plus 6 is 33. So minus 33 over h. So I've basically eliminated what could have been up to 3 steps by doing it in one, by just doing some things off to the side. So now, basically what should always happen, and if this doesn't, you should question that you've done something wrong, is that the numbers should all cancel on top.
Right.
But don't just go cancel without actually checking, because sometimes people do that and I'm like, 27 and 4 don't cancel. Like, just doesn't work. And then they've done something wrong, which ends up leading to the rest of it being wrong because something was wrong with what they multiplied by h or something. So 27 and 6 cancel with negative 33, so I can cross those out. And so then I'm going to just rewrite this off to the side here, and then I'm going to do the limit altogether. So that's going to be 20h plus 3h squared over h. And so when I factor the h out, I'll rewrite my limit. So the limit as h approaches 0 of h times 20 plus 3h over h. H's cancel, and so I'm left with 20. And remember, because these are instantaneous rate of change, they have units, which is feet per second. And now I should say they have units because units were given to us in the question.
Okay.
So the instruction specifically gave
No,
it.
it's just like
Not like
yes,
problem
yes,
24 doesn't say the units are feet per second, but the instructions for that section of
Yeah.
problem says feet per second.
Okay. Sounds good.
All right, so we'll probably look at 2 word problems, maybe tomorrow, 1 or 2 word problems. We'll see. And then you'll have the rest of the time to work on problems. So we're looking at, I think I originally had quiz up there for Monday. It'll probably actually be Tuesday, which works out because the physics test is Monday. So it kind of works out. And then maybe, depending on how y'all are feeling, maybe test Thursday.
Okay.
So
I don't
that,
think this chapter is too bad.
so we'll see. We'll decide, but it pretty much won't be Monday because we're not finishing the section until tomorrow.
Okay.